Okay, hello guys. Was it like on Tuesday? On Tuesday, I don't know what happened on Tuesday. Maybe I was tired, or maybe you were tired. But it was not a good class, right? Everything seems difficult. All right? So today I decided to review this class again because it's important, right? The goal is not just to finish the program, but the goal is to understand what we are doing here, right? There is no point of going pali-pali, right? If you don't understand, it's a waste of time. So today I decided to kind of review a little bit what extrusion cooking is all about. And I hope that if you have questions, raise your hand, ask questions, don't go home if you don't understand. There is no point. All right, so I watched the, I kind of review my notes again and the previous video, so I decided to review it. So probably today we'll finish early. But it will depend if you guys still don't understand. Alright? I'll try to go a little bit slower today. I'll come back to the assignment. The assignment I gave you based on the article that I wrote a couple of years ago on extrusion cooking. I hope that you already made some groups of 4 to 5 people. It's a very important assignment, as you know. The assignment talks about the effect of feed moisture and temperature. Now, what is all about? When I talk to you guys about extrusion cooking here, I gave you the definition here. Extrusion is a mechanical process exposing material. What is the material? Like things that you want to cook, right? It can be your flour, it can be your powder. In my case, when you read this article, in my case, what was my material? Chestnut, right? So, what did I do? I had to transfer the material. I had to change it, all right? And so what did I use? The technology I use is called extrusion cooking. Extrusion cooking, 2 main components, 2 main elements. High temperature, okay? And we also go with moisture. In moisture here, I'm talking about what? I'm talking about water, in my case. Okay? So, and then what happened? We exert some pressure, and it's done over a short period of time. Okay? It's done over a short period of time. So, as you can see here, today I will also play a 3-4 minutes video. Alright? As the video plays, I will explain again what's going on there. I had my own video a couple of years ago. I lost it when I was doing this research. Okay? So, on the paper, we talk about the effect of feed moisture. Feed moisture here, we are talking about the water that I used. And temperature. If you look on the paper, I use different temperatures here. Okay? I hope that by now you already checked the paper, okay? I really hope, And so you can see that I use different temperature, and then for my experiment, the one I went yielding results, I have 120 degrees Celsius, and I have 140 degrees Celsius. Now remember, last week we talked about 2 types of preparation or cooking. We talk about what? We talk about the dry cooking or the wet cooking. Okay? So, but with this one, where we can have two types of extrusion cooking here. What are the two types that I mentioned yesterday, on Tuesday? What are the two types? Extrusion cooking. What are the two types of extrusion cooking we have? Hot and then cold. Okay? So you have it here. Now, very interesting, guys. The cold extrusion is below 100 degrees Celsius. And last week, when we look at the wet cooking, we talk about the simmering, we talk about boiling. So the temperature is actually very important here. Okay? Cold extrusion, below 100 degrees Celsius. And then we have hot extruders over 100 degrees Celsius. So, oh, you guys are taking pictures? Pictures of me or of this? You can take my picture too. Alright, so now, when we look at it, now we talk about the extruders. Basically, we are talking about the screws that are using in the mixing of the material. Okay? And we talk about the single screw extruder and the twin screw extruder. Alright? In my experiment, I used the twin one. Okay? So you have the single screw extruder here, and then you have the twin one. All of that working on the mixture. Let me go back to the first page. Let's come back here. This is how your machine looks like, and I will show you the video so you can really see the machine here, right? So, what is taking place here? You have the hopper here, basically where you put your material. The filter, your material is coming out of this, and then the material will enter through the barrel. All of this is the barrel. Inside the barrel, you have the screw. Okay? So the extruders, right, it helps us to make many different kinds of nutritional food. Okay? So based on the temperature that we're using, and also based on the dye that we're using here, you see the dye, when the food is coming out, the shape of the dye will basically decide how your food looks like. Okay? For example, okay, so we have this dye, and then the exit can be like this. Okay? So, under pressure, because some pressure will be exerted when the food is coming out, okay? The food will come out through here. Of course, it's going to be expanded, but very quickly, it will come back to the form of the dye. Alright? It's going to dry fast. Then, you're going to have like your pasta, and you call it these spaghetti, rotini, different forms, right? The shape goes with the dye. Okay? You guys eat these kinds of food every single day, right? You go to the movie, you have like these potato chips, you have pasta. Even, how do you call it? I don't actually like that food. Food that I don't usually like sometimes, I forget the name. Hot dogs. You guys like hot dogs? You don't? Alright. But the hot dog will be, in the case, for example, here, we can use it in the case of cold extruders. Alright? In the case of cold extruders here. So, the barrel, is filled, the barrel will be filled with the screw. So here, you have the oil process. You have the oil process here. The top left, the ingredient, the mixing started, you have the extruder here with the screw, and then you're dyeing. Basically, this is the whole process. Nothing really fancy, nothing really like amazing. I mean, it's amazing, but I meant by that, nothing really difficult. But it takes time. When I did that experiment, I had to do a lot of trials to actually get what the nutritional properties I was looking for, and then I will explain that part in a few minutes. Alright? So this is, if you want, the mechanical part. Alright? The mechanical part of the technology. And then when we get the food, what do we need? We now need to check the physical properties of the food, how the food looks like, is it crispy? We can check different chemical elements of the food. We are checking the nutrients, alright? What happened with these nutrients? Do I have more of this nutrient or I have less of this nutrient? And in that case, like I told you guys, the goal, what is the goal in terms of nutrition? We want to be making functional foods. You know, for example, foods for babies as well. Okay? We talk about functional food, we talk, oh, I need fortified food. I'm adding new nutrients into the food. When we started the class, you know, I used to draw this picture, oh, we add vitamin C, we add iron. So now we have a process where we have our mixture of ingredients, where we can now make specific food. Okay? Why do we make this fortified food? The goal is what? To reduce the risk of chronic diseases. Simple. Okay? So, once again, I don't teach for grades, and everybody knows that. I don't really care much about the grades. But I sincerely hope that everything that we learned here, you can visualize. You know, when you go to the store, you have an idea, oh, this was made this way. You know how to read the food label. You know, you understand what it means enriched food. You understand what it means fortified food. At the end of this class, that's the goal. The goal is, from next week, as we start looking at problems of obesity and hypertension, the problem of cardiovascular disease, the problem of diabetes, now you also have an idea how, nutritionally speaking, we can deal with these problems. Alright? And for those who are in food technology, it's a great opportunity to understand that, oh, okay, this is how things work. So, this part, you're going to have a little heat. We talk about high temperature. Okay? And the screw will be like helping in mixing. You have the feeding part. So, it's the same system. And then, on the pressure here, it comes up. Usually, it comes up very, very hot. Never put your hand around here. Very dangerous, very, very hot. Okay? And then, you know, the moisture that was used is going to evaporate very quickly in the form of steam, you know. So it's actually a good way of making functional food. So during my postdoc studies, I had to do this with the Korean chestnut. Okay? So, and I will talk about the nutritional properties in a minute. But before it, let me play this YouTube video. I lost my own on a USB key, but I found this video that is equally interesting. What happened? It's not playing? Alright.
It's very far above my expectation.
So I will explain to you guys. Alright. So this is the machine. Alright. So just take a look. You can look. You see where the gentleman is standing here. This is the feeding part. Alright. And you're going to have your screw inside, and everything is automated. So you can set up the temperature actually from here for those who may be interested in that.
My name is Paul Evenhouse. I'm the technical specialist.
I'm just going to jump into some parts. So you have the whole
scale or laboratory type of extruder. It produces a wide range of products, anywhere from breakfast cereals to pet foods, snack foods, snacks.
So you can see the different kinds of food that we make through extrusion cooking.
For twin screw extrusion, dry ingredients go in there.
So you have the filler there.
Liquid.
It's mixing the whole thing.
Use water. Water inlet is right here. And everything's run with the computer here. Our screws will turn anywhere from 0 to about 500 to 700 RPM. And we can adjust the heat or temperature. We have 9 different heating bands here. And we can adjust the temperature from room temperature up to about 300 degrees Celsius. And at this end of the extruder, we'll just put in a coupler and we'll insert one of our dies. For length, what we do
this is the die?
blade.
You see the food is coming out of the die here.
And it's a variable speed cutting blade. And if you make different products, you make like corn balls, we'll have the knife running about, for example, 2500 RPM. And for like a cheesy type product, the long curls, we'll have a knife running about 200 RPM. So the difference between those two products is the speed of the cutting. Most we're making about 50 kilograms per hour. We're just simulating basic commercial process, and in a commercial plant, those machines are running like hundreds to thousands of kilograms per hour. And we just have a small scale coating machine here, and this drum is quite small. In a commercial plant, the drum will be about skinny and an apple, about 10 feet long. Now, for coating, usually we'll spray it with oil or sugar slurry. And for the oil, it just acts like a binding agent or adhesive. So when we add dry ingredients to the product, the dry ingredients will stick to the oil. So the liquids we'll just put in this container here, and they'll be pumped to 2 spray nozzles. And while it's spraying the product, this drum will be slowly turning. So the whole process, for example, about 5 gallons of product takes maybe 5 minutes. And for packaging, once we're done that, typically like for handouts or foreign shows, as an example, we have a vertical packaging machine here, and we're able to make the packages anywhere from about 10 to 20 centimeters long. And we just have clear packaging that's sort of environmental friendly, corn-based packaging that's very strong over time. We do a lot of projects with our pulse crop area, so they can gather knowledge on how to make, for example, breakfast cereals out of chickpea flour, lentil flour, pea flour. Basically, it's just another tool that we can use to show our customers how our Canadian grains can be used. Another use, things like promotion and what, basically lately with gluten-free products. We've done a few projects making gluten-free pasta. And yeah, so that's what we find is the machine's becoming busier as time goes on.
Okay. All right. So I hope you guys saw a little bit. You can visualize a little bit now how this process is done. Actually, it was like a Canadian company here. All right, so now, we talk. So we talk about the 2 types of extrusion cooking that we have, and I think that you have it here. So I told you that we have. The cold extruder, right? And we have what? The hot extruders. Okay? So just to remember once again, for the cold extruders, usually in a temperature below 100 degrees Celsius. Okay? So, in this process, the product is extruded without cooking or distortion of the food. All right. This is the first element when we talk about the cold extruder. Another thing about cold extruder is what? Usually is low speed. So we have the low speed in a small barrel, and the type of food that we produce with them, usually we use a cold extruder to make pasta and things such as hot dogs and pastry dough. Okay? So when it's low speed here, usually we have a little friction. We have little friction usually here. Most of the time it's actually pretty smooth. All right. So can I erase this? Can I erase this part? No, not yet. So cold extruders below 100 degrees Celsius. In this process, the product is extruded without cooking or distortion of the food. All right. And another important element. This is the extrusion technology we usually use for making pasta, hot dogs, pastry dough. Good. All right. So I'm just trying to basically summarize what we saw last time. So what did we say about the hot? What did we say about the hot extruder? So this one, we already know the temperature is what? Over 100 degrees Celsius. All right? Okay, we know that. So, so what is the characteristics here? The hot extruders, or if you want hot extrusion, minimizes the loss of nutrients and reduces microbial contamination. You cannot see? Any word you cannot see? Which word? Minimizes? Alright, so here, your face is funny. Any word you cannot see? Can you read? Yes, no? So on the pepper, an important element that we look at the pepper was what? We talk about the microbial aspect of it, right? Like antimicrobial. We also talk about the presence of nutrients, right? We're looking at nutritional benefit here. So what kind of food do we usually make with this one? Things like crisp bread, and as you're watching on the video, he talks about what? Breakfast cereals. Okay? Okay, guys? All right. Can I raise? Can I raise? All right. So now, when you read the paper, there were 3 elements. So, number one, we look at what? The first element we look at was what? We look at the tannin content, all right? So, yeah, you know, tannin can be good depending on the dosage here. But the thing is, we know that this substance, number one, is bitter. Okay? That was not the first element. We say, oh, we want to improve this food. But the food is bitter because of the presence of tannin. Chestnut is good, but we want to remove the bitter taste that is associated with the presence of tannin. So the goal is, okay, through extrusion technology, can I reduce tannin content? Alright? So the number one thing we wanted to do was what? We wanted to reduce tannin content. Okay? And the other element, we talk about the second one, the affinity of tannin with some protein, right? And that may hinder the digestion, all right? So because of you say, oh, okay, maybe it's probably better that we reduce tannin content here. So on the pepper, that was the number one element that we have to look at. Can extrusion cooking reduce tannin content? That's the question that we asked. Right? So how do we know it? So we look at raw and then after extrusion. Alright? So we look at the same concentration. You can look at the pepper and say, oh, okay, we have tannin in the raw form. We have this quantity of tannin in the beginning. Meaning this is chestnut, we didn't do anything. So what I did in that experiment is, okay, I test tannin content without touching the original third of the chestnut. Alright? So we measure it. And then we go through extrusion cooking. As you see, I use different values. 120 degrees, right? We use different moisture content. If you read the paper here, you can actually see. So we have 120 degrees Celsius, 25% moisture, and all of that. You see, all of that, as you saw, on the video, you can actually set the temperatures. It's automatic. It's a very good process. It's actually pretty safe. You can set up the temperature, the moisture. You say, for example, you can set, you say, okay, I want 120 degree, 25% moisture. I want 120 degrees Celsius, and then I want 28% moisture. And then you can also say, okay, this time I want 140 degrees Celsius by what? 25%, and then 140 degrees Celsius, and then I want what? 28%. You see? So here actually, you have 4 different results. Okay? You have 4 different results, and you try to see which one is optimum, which one is better, which one reduces tannin content more than the other ones. Alright? And then you can just say, oh, okay, probably this one is the one that gives me the best result. So, raw tannin, we are here. After extrusion, we just realized that tannin content is actually much lower. So conclusion, yes, extrusion cooking can reduce tannin content. By reducing tannin content means, oh, okay, number one, I can solve the bitter taste that we get from chestnut. Number one. Number two, oh, maybe I can improve the digestion of that product because of the affinity with protein. All right. Okay. So now, number two, what did we look at? So we look at antioxidant. So we ask the question: can extrusion cooking, can extrusion cooking improve antioxidant property of chestnut? Okay? So it's the same experiment. We check with ascorbic acid. I check with another one too there. So it's the same thing. So we compare raw, and then we compare after extrusion. Okay? So, and then what do you realize? Alright? If you look at the paper here, for example, we look at, which one will I take here? The antioxidant property here. So we can go, for example, this one. On the paper, you will see that it goes from around 12% to what? 12% to 21%. Right? So it means that extrusion cooking increases what? The antioxidant properties of chestnut. So what does it mean? We talked about antioxidant. So okay, now we feel happy, right? Now we can fight some disease, like we said in the beginning. The goal is to reduce what? Chronic disease. We want to fight cancer, we want to fight diabetes, we want to fight other chronic diseases. Alright? So that's the way we think. Why am I doing what I'm doing right now? So you check the original, and then you check after the experiment. Remember, what else did we say about, for example, hot extrusion? Because that's the one I use in my experiment. Alright? We also say, okay, we can reduce contamination. Remember the chapter on food safety. Right? The presence of bacteria. So we use some bacteria. So what do? That was the third part. We want to test what? Antimicrobial properties. So how do we test it again? We do what we call, in this one I did 2 experiments. what we call the minimum inhibitory concentration. It means which concentration I need for the bacteria to stop growing. I don't want the bacteria to keep growing. Alright? And I also use the second test that I did was what? The time kill. Like, you want to make sure that the bacteria is completely dead after 24 hours. Alright? So, you do the same roll, and then after extrusion. Okay. On Tuesday, I showed you for the minimum inhibitory concentration. So let's look at this one. Alright? So you will see, please, I hope you printed the paper now, right? I hope everybody has the paper. Okay? So you will look on the paper. I use different time here. I use 4 hours, 12 hours, and 24 hours. Alright? So then we have here, of course, this is 0. 0, this is what? This is the bacteria count, right? So we have 0 here. You see, is so we start. We have like different levels here, and here I come and check after 4 hours. I check 8 hours. You have 12 hours. And then you have 24 hours. Alright? So if you look at the paper here, you're going to see, okay, so for example, we start here. This is the quantity of bacteria I had at time 0. Time 0. So, it starts to go down a little bit, and then at 12 hours, it's high, very high. And then at 12 hours, it's super high. Okay? Alright. Then, this one is what? This is raw. This is raw chestnut. Okay? Raw chestnut meaning I did not change it. This is the way we eat it. Okay? Okay. Alright. So now we do the extrusion. The same thing. We start here. The quantity is the same, isn't it? So, you have the same thing, but if you look at it, what is that paper? So you look at it, it seems to grow a bit. It seems to grow a bit, and suddenly is going down to 0. You understand? So you see, the trajectory seems to be the same for the first 12 hours, alright? But when you look at the paper, from the 12th hour here, alright, you can see that the quantity of bacteria is actually going down. Conclusion, extrusion technology has the ability to suppress the growth of bacteria. Not all bacteria though, not all of them. I only chose some bacteria, so we have to be careful. So if you need to work with some bacteria, you really have to be careful here and really make sure, because some bacteria can be resistant. Alright? So we will see that, okay, we have a good result here from the 12 hours to the 24 hours. So what does it mean, guys? It means that after 12 hours, we don't have a significant presence of bacteria anymore. Okay? Alright guys, so that was for me. This is what I wanted to show you guys today. If you still have some questions, I will be here and I'll answer to your questions, and I'll see how I can help you further. Alright? So I hope it brought a little bit more clarity this afternoon. And that's it for the second part of this chapter. Next week, we will start talking about diseases now, talking about hypertension, cardiovascular disease, talking about diabetes and renal disease. Hopefully we'll have a time for it. Okay? Okay guys, have a nice day. I will be here as usual, and I will be happy as usual to answer to your questions. Alright?
Oh, this is a washer floating. Like water quantity. Yeah. The washer releases water, right? So, let me say,
engenge nyonso awa yomponi motema nanga tika nangenga yawe yoboko ekatisaka mibale eza ya yo Yesu yoboko ekotaka tina motema eza ya yo Yesu iloba nanu ebimi na monoko te oyebi nyonso bitumba oyo ngananu napundi te deja yopesi elonga ya ngola koemba na koemba o yawe yawe basi na ngai esengi nani yawe basi na ngai ezosinga nani
Nzamba bokeseni osalaka lolenge ya bato ya mokili te mpe bisika lolenge bino mbulu tikali mpona bikeke na bikeke
nzambe na nga nzambe ya bokeseni oyebi nyonso obataka esika moto asukeli oyemba nzembo esika nazokende deja yobutikuna obongisi nyonso nzambe na nzela yoche na moto natamboli na assurance elongi ya mosingala lokola libende batie na moto basololaki na yawe komonga moto nabemi yo na nzoto nangenga te ndenge nini ye ozali nzambe yane motenga nanga aleluya
nzambo ya kambolaka
yawe
eza yo Yesu
aleluya nzambo yasalaka makambo kozanga toli oyebi nyonso ozalaka na posa te babetela yo lisolo oyeba vi ya moto nani abilila yo asangwa nani alanda yo afunga nani achila yo motema yoka soni esalema wapi nzambe nanga nzambe ya bokeseni nzambe ya différence Yesu bokeseni Yesu salelanga makambo ya bokeseni ekoma lisolo akobeta na kelasi to na mosala ekoma témoignage avenu nanga bayoka sango fami nanga bayoka sango nzambe nanga asali ya bokeseni etikala sango il est vivant Yoshua lokola za vivant bakosala kaka Yesu aza na nyonso nzambo ya ngai soki azana nyonso nga mpe nazana nyonso kati na ye elelelelile 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 zamoyo sungae
Elombe Yesu Nzambe banga Célibato masque de vieillesse esengi nani esengi nganga kisite tata mwasi ya koko eloko te bisika na kosukela nani akokomba ye